Machine learning and artificial intelligent models really do not like object columns. That is why you have to use encoding in order to get around this problem, and really that allows you to have a successful machine learning and artificial intelligent model. So sit back, relax, be your favorite snack, and let's get started, shall we? Hey honors, welcome back to another episode of Islander Robotics, where today we're going to be talking about something that's going to be preventing programmers' headache, essentially. For those of you who are brand new to the channel, my name is Will, and you're watching Islander Robotics, where we're using Python to learn applications of machine learning and artificial intelligence through demonstration. Today's video is no different than any of the other videos when it comes to machine learning. Encoding your data is actually really important because machine learning and artificial intelligent models really dislike object columns. So encoding your data set is actually a way to get around this programmer's headache by essentially turning everything that's within that objects column into a bunch of categories. What I'm talking about in categories, you'll all see in a couple of seconds, but what we're going to actually do is head over to a Python console where you all will get an idea of what I'm talking about on columns that are object columns. So when I hit enter, we're going to be calling upon our data discovery module that we created a couple of weeks back, where we're going to be getting a few different questions, where we're going to say yes to this one to actually evaluate the head method. And it's going to allow us to see that ocean proximity has some strings in it. That's going to give us an idea that that column is actually an objects column. It's going to be further backed up when we actually hit yes again. And it's going to tell us that ocean proximity is an objects column. So what we're going to do is use various different encoding strategies to actually take that object column, break it up into all the type of categories that are within that column, and then allow those categories to become the data that gets plugged into our machine learning model. Now, I said earlier I would talk about what is a category for an encoder. Well, if we hit yes on the next one, we're going to be able to evaluate all the various different categories that's going to be used for this one specific data set. So let's just hit yes. Now what you can see is that our categories are going to be made up of all the various different strings that are within our column, within that one column. So 1/2 greater than 1 hour ocean is going to be its own category, and inland is going to be its own category, near ocean is going to be its own category, and so on and so forth. Those are going to be our categories to allow us to use various different encoding methods. Now, the very first method we're going to actually use in order to actually encode our objects column is going to be sklearn's ordinal encoder. And the way that we're going to do that is just simply by coming over to our Python console and actually saying from sklearn.preprocessing import ordinal encoder. Now when we enter, the next thing we have to actually do is actually create an instance of the ordinal encoder. It's actually pretty simple. You just say encoder equals ordinal encoder. I spelled that wrong. encoder. Now parentheses, when we hit enter, we're going to have our very first instance of this encoder. Now, in order to actually convert our objects column into something that's more manageable for our machine learning model, what we have to do is call upon the encoder.fit transform method, which is encoder.fit transform, and what we're going to say is data at the column name of our objects column, which is ocean proximity. Now, if we were to just hit run right now, there would be one giant error, which is what you see all right here. And the reason being is because our ocean proximity is in a format that our fit transform can't understand. So in order to actually get around this, what we have to do is say dot array dot reshape -1, 1. Now when we hit enter, there will be no issues. Instead, what we get is a numpy array where each one of the cells is going to range from anywhere from 0 to the length of our encoder.categories list. Now, what is the encoder.categories list? Well, in our circumstance, it's going to be whatever those values that were inside of our cell originally. So in order to actually access that, we're going to be calling upon encoder.categories. When I hit enter, we're going to get all the different values within that one cell. Within that one array. Now, if we want to double check this information to make sure that it's all working properly, what we're going to do is just say call upon encoders.categories. This is actually a matrix, so what we have to do is we're going to say 0, and what we want is 3, because the value of our 0 index within our encoder.fit transform.array.reshape is actually the value of 3. So let's just put in 3. Now when we hit enter, we're going to get nearby. We can actually compare this because as of right now, our code is considering the encoder.fit transform as a completely separate array compared to our original dataset. It hasn't done anything to our dataset. So it's pretty simple to actually double check what is going on. So we can say data at ocean proximity. When we hit enter, oh, I spelled ocean proximity wrong. Yep. Now enter. 0 of that column is near base. So everything within our ordinal encoder is 100% correct. So the next thing we're going to want to do is actually add this array to our data set. And the way that we're going to do that is first by actually calling upon the encoder.fitTransfer method again. But instead of just saying encoder.fitTransfer, what we're going to do is we're going to set this value to a variable by just saying new data equals encoder.fitTransform. So when we hit enter, all that information within that encoder.fitTransform is actually going to be stored into new data. So now what we can do is actually drop the old ocean proximity by just saying data.drop columns equals, and then we're going to also say in place equals true. So when we run this, our ocean proximity is no longer exists within our data set, but we still have the information stored within our encoder and our new data. So what we're going to want to do is actually say data at ocean proximity equals new data. So when I hit enter, all that information within that one data set, well, within that column of our data set is now going to be converted into the information that we were seeing within our ordinal encoder. So when we say data.info, what we're going to get is we're going to see ocean proximity is now a float 64, which is exactly what we want. There's one problem I have with this method, and what it is actually is that since all the values within all these cells are going to vary from 0 to the length of our encoder.categories list, there's chances that some values within this column will actually be weighed more inside of a machine learning or artificial intelligence model than others, when in retrospect, a majority of the time when you're dealing with categories and when you have to encode the data, there isn't always a category that's going to be that you want to actually be weighed more. Therefore, the next method is actually going to be a solution around this problem, and this method is going from actually the same Python package as ordinal encoder. Some of you probably have heard of this. It's called Hot Encoder, and honestly, it is probably one of the best types of encoders to use with your dataset. So in order to actually be able to use the Hot Encoder, what we're going to do is switch over to, of course, a Python console. All right, so within the Python console, and I kind of just skimmed over and added a whole boatload of code because ordinal encoder and Hot Encoder are very similar all the way up to where we're actually creating the new data set. Essentially, where we're going to have new data is actually a different type of data set, where we're going to actually come over to here. We're going to try viewing new data. When I hit enter, what we're going to get is a sparse matrix of a NumPy array float 64. The reason being is because unlike the ordinal encoder where each category had an associated number within that one column of ocean proximity, Hot Encoder is actually creating as many columns as are in our encoder.categories list, and it's going to be creating a column for each one of those, where if that original cell was not equal to that column, what's going to be equal to is now 0, and until it actually hits a column where the original cell was actually equal to that category, it's going to be a 1. So basically, Hot Encoder creates a matrix that's filled upon thousands upon thousands upon thousands of zeros, unless that one specific spot in that row is actually going to be equal to 1, where the original data was actually equal to that category. So what we're going to have to do in order to actually convert this sparse matrix back into an array is just reinitializing new data to where we just have dot to array. Now when we hit enter, you're going to now be able to see what's within our Hot Encoder's new data array. So as you all can see, there are a lot of zeros within this one array. There are more zeros than there are ones, and this allows us to actually be able to not have one column to be having a more of a weight than the other columns itself, going around that problem that the ordinal encoder had. Now, in order to actually add this to our dataset, because remember, as of right now, our dataset, our code is considering new data and our original dataset data to be separate datasets. So in order to combine them, the first thing we're going to have to do is actually turn new data into a pandas data frame by just saying converter equals pd dot, no, not array, data frame, and we're going to say new data, and we're going to set the columns equal to encoder dot, did I spell it wrong? Yeah, I spelled it wrong. Encoder dot categories. Now when we hit enter, we're going to be able to see now is converter is a pandas data frame where each one of those categories is now equal to its very own column. Therefore, now what we can do is drop ocean proximity by simply just saying data dot drop columns equals x. So for the sake of time, x is actually equal to the string array of ocean proximity. There's really two reasons why I did this. One reason is for the sake of time, as well as the other reason, I'm pretty sure you all can tell I can't spell to save my life. So instead of me trying to embarrass myself, x is now ocean proximity. So the next thing we have to do, because if we were to run this line just as it is, it would actually erase that data, that column, and then re-add it as soon as this line was done. So to get around this, we're going to say in place equals true. Now when I hit enter, ocean proximity is no longer part of our original data set. To add our new data set back into our data, the encoded version of it, what we're going to do now is actually create a for loop. We're going to say for I in converter dot columns. And we're going to say data at column of I equals convert at I. Therefore, when we run this for loop, all the new information that convert had is now going to be added into our data. So when we say data at I, and we hit enter, wait, no, not I. We're going to be seeing our whole data set with the new information added to it. And if we were to actually just go data.info, what we want to make sure of is that those new columns aren't object columns. They're either a float or an integer. So when you hit enter and then look over this, we can see ocean proximity is a float 64. That was one of our categories. Inland, inland's in added twice. Inland and then island. I read that wrong. I don't got my glasses on, okay? So inland is also a float 64. All of them are float 64s. All right, Islanders, I'm super sorry. I really cannot read without my glasses. But one hot encoder is honestly the most robust encoder there is out there. However, it's very complicated actually to implement one hot encoder. So the next encoder I'm going to show you all is actually the easiest encoder to actually implement and is just as robust as the one hot encoder. And it's going to actually going to be a Python package specifically designed for this community, Islander Robotics. And honestly, I'm so happy and proud to show you all this package. I've been working on it for the past few weeks, and it's actually a combination of all the modules that we have worked on within this data preprocessing class. And in order to actually be able to access this, what we're going to first of all have to do is get our data set. So we're going to say is import pandas, P-A-N, PD. Now what we're going to do real quick, down in the description bar down below, there's a GitHub link to all the code that we were talking about throughout this whole video. I'm just going to be grabbing the line that we have for data. So real quick, just copy and paste this, Command C. So go check that out if you're very interested in wanting to digest ordinal encoder or one hot encoder. But our little package that we got going on right here is going to be the easiest way for you to actually implement both of them. So once we have our data set, the next thing we have to say is import Islander data preprocessing. Now when I hit, I want to do one thing. As I want to create an alias because that is one heck of a long name for a package, but I'm very proud of that name, so I'm just going to enter on that. Now we have Islander Data Preprocessing as IR. In order to actually be able to call upon our encoder module, what we're going to be doing is actually saying encoder equals IR dot encoder, and then inside of this within this parentheses, what we're going to pass in is our data frame. So we're going to say df equals data. Now when I hit enter, everything is now imported into our IR.encoder module. Next thing we have to do is actually call upon the check method. All the modules within this package is going to have a check method so that you have access on whether or not you want to actually implement that section of the package at that time. So in order to actually call upon and make changes to our data set, what we're going to have to do is say encoder.check. Hit enter, and then to evaluate everything that's inside of our brand new data set, what we're going to say is encoder dot, oh, did I spell it wrong? Yeah. Dot df, and then if we hit dot info, what we're going to see now is that all of this data within our original object column is now going to be encoded as a one hot encoder. So if you look down here, we have more than an hour from the ocean, inland, island. Kind of sad since the name of the channel is Islander Robotics, but near bay and near ocean are all imported into our data set. Now, in order to actually call upon the ordinal encoder, you actually do have the option to do that by just simply coming back up to where you are initializing the module, and then within the parentheses, we're going to put a comma, and we're going to say type equals ordinal encoder. Now when I hit, oh, I spelled encoder wrong again. I typed too fast. When we hit enter and then do check again, and now back to info, we can see ocean proximity was encoded as a ordinal encoder. This Python package honestly was designed for all of you islanders to have a smoother and easier transition with machine learning and artificial intelligence. Yes, right now we're making data preprocessing a better experience for everyone, but as this channel is going to grow and we get more experiences with machine learning and artificial intelligence, so will this Python package. So what I really want to know is there's going to be a pip command up on the screen right now. This Python package is still in developmental stage. Use this pip command right here or down in the description bar down below. It's the same pip command to install it straight from GitHub, and let me know down in the comment section down below of this video or any video really on what you all think about the package. Let me know what I could change about it, how I can improve the module, and all that fun stuff. I want to know what you all think so we can make this thing one awesome tool for not only the Islander community but for the rest of the world. So don't forget, leave those comments down below on what you all think about this package. And while we're talking about the comment section, don't forget that there's going to be a Q&A at the end of this month. In order to actually get in order to get featured in that video, you have to leave a question down in the comment section down below. It can literally be any question you want to know. Leave it down in the comment section down below. As always, happy coding. I love you all. Thank you so much for watching, and I'll see you all in the next video.